Hello everyone, welcome to the knowledge session. I'm Pranjit Gogoi and I'm going to talk about TensorFlow and, for deep learning and NLP. So I was thinking of giving the session on TensorFlow only, but later on I realized, only TensorFlow don't make a lot of sense. Right? So yeah, I have added like deep learning and NLP into it. So, so here is the agenda for today. So we are going to have an introduction to TensorFlow. We are going to have an introduction to deep learning, NLP, and then we are going to see a problem statement which we are going to solve through these topics. Okay. Just for a change, let's not go from the top to bottom agenda list. Then let's go from the go in a reverse way from bottom to top. Okay. So here's the problem statement. What we want to do, we have give knowledge feedbacks to the presenters, right? So what we want to do, we just want to categorize those feedbacks, right? So so like humanly, it is very easy. We just need to read it and we can find out if the feedback is good, bad, or is it about improving, and that sort of stuff, right? And thanks to Nitin, Anmol, Raman, Harmeet, and Anuj, who has actually shared their knowledge feedbacks. So whatever the example that we are going to see on kind of live data. Okay. Now, of course, we are going to solve this problem through a machine learning algorithm, right? But the challenge is machine learning algorithms takes numerics as inputs and not text, right? So, and what we want to do today is we just have the sentences, we do not have any label to it. We want to find the labels, right? So, which means it's a clustering problem, right? And for solving clustering problem also, the algorithms K means wants numeric values, right? So, in order to solve this problem, right? And let me talk about clustering a bit so that you'll get the idea. So clustering is, here's the definition, right? So clustering is the task of dividing data points into number of groups such that data points in the same groups are more similar to other data points in the same group and dissimilar to the other points, right? And you can see the graphs as well here, right? So these are kind of data points which are getting categorized. So and it is colored as well, so I think you can get it easily, right? So normally what happens whenever we have this, whenever we have to do clustering, we have this kind of data, right? This is a normal data set for machine learning algorithms, okay? So we have 5 columns here. However, clustering is unsupervised learning algorithm, okay? So when it is unsupervised, that simply means this column won't be there. There only be these numbers. So we need to find out what these numbers are, where they actually belong, right? So right now we can easily see that these numbers are belong to these 3 categories, right? All right. So now we do not have these numbers, right? We have just the words. So what we need to do, we need to somehow convert those words into numbers and then apply all the algorithm to find the labels, right? So now introduction to NLP. That problem we are going to solve through what? NLP, that is natural language processing, right? So, and here is the So this is the definition for natural language processing. And if you see here, there is a part where it is saying this one, and artificial intelligence concerned with the interaction between computers and human language. In particular, how to program computers to process and analyze large amount of natural language data. So we definitely going to work with human language. It's just that we this interaction thing would be one-sided. So we are just going to fit in, and we are not expecting our computer to give a complete sentence or something, right? That would be again, that comes under the NLP only. You already know about the chatbots, right? There was a session in Tech Reveni as well, right? So so the thing is, we'll be So we'll be going through NLP one by one. So this is how NLP works. Okay, so it'll just read the human language text, right? It will apply some complex filters, and then it will find some results through which we can again translate those results back into human understandable words or sentences, right? So now, so these are the terminologies that we need to understand, if we have to work with NLP. And these are few models that we are going to discuss today. So there are a lot more algorithms are there, but yeah, let's limit us to these algorithms only. So these are terminologies like corpus and word embedding. So the easiest way to remember this terminology is the corpus is the input and word embeddings is the output. Okay, corpus is what the text is, whatever the text data you have, right? That is called corpus, and whatever the machine learning algorithm will be applying in that corpus, it will result what the word embeddings. So it will be like a map and those numeric values, right, which we are going to process. And then these are the models that I have actually tried the data on, right? So there's word2vec. So this model is being invented by Google, I think in 2013, right? And these are the two subcategories of this model, right? So basically it converts those words to a to a vector and then process on it, right? So let's go one by one. I have practical examples for these models as well, but let's keep it for towards the end. Okay, I mean let's just understand what it is right now. So this continuous bag of words. Okay, so what does it do is it takes context word as input and it results a target word back, right? So so whenever whatever the document we have, whatever the sentences we have, right? So every sentence must have one context, right? What is this sentence is representing about, right? And if we have to, for example, if we take this sentence, right? I mean these words, I mean, right? Build the corpus vocabulary, right? So here, if we say build the vocabulary and probably NLP as well, one word here, probably just guess it, right? So what would be the target word? It would be corpus, right? So yeah, I mean you got what is context and what is target word, right? Target word is the word that we want to predict from the words that is being given as input, right?
The target word has to be in the sentence itself, or it can be custom generated.
I mean, we have to fit the words, like this corpus thing, right? It has to belong there.
The target word comes from the corpus itself.
Yeah.
I believe we are providing weightage in
We'll come to that later on. I mean, let's just focus on the mechanism, right? So yeah, I mean then we will generate one mapping, right? So there would be context and target mapping that there are tools for that, right? I mean we can do it through manually as well, but of course we have computers, so we'll be doing that through them. And so then this model architecture, basically this is the model that we are going to build, right? The algorithm, right? All those parameters and how we will be constructing the model in order to filtering in the data, right? And then we'll train the model with a corpus, and then we are going to get the word embeddings, right? So yeah, and this is basically the image of the architecture that we can follow, right? It is basically representing a neural network, right? And yeah, I mean we are going to talk more about it in the deep learning section. Okay, we are going to have a introduction to deep learning as well later on. So then there is a skipgram. So this is reverse of continuous bag of words. Okay, now here it sounds like the name continuous bag of words. It sounds like streaming of data, but it is basically it happens because, for example, if we take in this is the target word and these are the context words. what happens whenever we put it in the vector, it need not to be in a like in a order, right? So we can just keep all those context words into that vector, and that's why it is called like continuous bag of words. Then skipgram. I mean, it is reverse of continuous bag of words. Uh, it it takes the like target word and give you the context. Okay, and in order to like it is again similar to the continuous bag of words only, like how we are going to proceed into it, right? So we have the like corpus, and then so here in the previous one, what we had like we had the context words, so we have a vector of words, and then we have the target word, right? For skipgram, what we have like we are going to have some this sort of stuff, like uh, we have the target word, right? And then we have the context word. So we are like pairing them, and like we are trying to generate like two kind of data, right? One is like if the target and the context word match, we are assigning them a level 1, that is true, we can say, right? And then we are going then next what it does, like it takes the target word and randomly picks any word and put into it, and it assign it as 0, right? That means it is false, right? So it creates that sort of like data, and then again it then we create a model for that. We train the model, and then we get the word embeddings. And from the word embeddings, whatever the operations we want to do, we can do with it. Now this is there's one more model that I have that is like Glove. That is global vector. So there is one tool called Spacey, right? I don't know if I'm like pronouncing the word correctly or not. So it's Spacy. Okay. So now what happens? The glove and the continuous bag of words, right? So we give the corpus, and whenever we train it, it takes a lot of time. I mean, in fact, I have tried to run the continuous bag of word yesterday to show a demo here, and I have like there are some example corpus already present in the tools, right? So I've tried some one of the Bible, which has around I think 30 lakhs words or something, right? So I have processed that, and it took around like 8 hours. So I have run it at night, and like it got finished in the morning. Okay, and of course I have this like I have done it in my local machine. So in order to do that sort of modeling, we require the GPU and TPU sort of like machines. But Glove it has like created one mechanism through which this training time reduces to we can say nothing in comparison to the times that a skipgram or the continuous bag of word takes. Okay, so how does Glove do it? I mean, it gives some of the commonly used words into it, and then it reuses all those words. Okay, so whenever we have to like work, whenever we have to train our model through Glove, we will be like giving two like inputs. One is one which uh, which is already present in its library, and then it's our corpus. So it easily like trains the model in that way. Okay, so yeah, I mean that's all about like Glove, and yeah, I've basically make the same notes here. So it creates a co-occurrence like matrix which is already present, right? Um, so now we have these models, right? So all these models belong to what? Deep learning. So what is deep learning? It's do you guys know what is like neural network? Okay. So neural network is an like information processing paradigm that is inspired by the way biological nervous systems are, okay, such that brain process information. So um, we have this like axon and synapse and all those stuff, right? So which are like kind of nodes connected by some sort of like edges, right? Just like this one, right? in our brain it happens through the chemical like stuff, but here it is digital, right? So I have given one like neural network session earlier. It sounds like no, you guys definitely do not remember that. So try like find some videos in like YouTube probably, because I mean it's a big topic. I mean I cannot like talk about in just like 1 or 2 minutes, right? It will take a whole session. So it's just that I mean the way it works is like these are there are like number of inputs that we are going to give, right? We will be having some weightage here in this like edges, just like Manish has mentioned earlier, right? And then we have some like mathematical operations in these nodes, right? And we are going to get the outputs. So whenever we have this hidden layer, right? I mean this is the layer where our data got like distributed. And when we have like more than one layer in the network, it's called deep learning, right? So like deep learning is not a new thing. It is like it has been there for a very long time. It's just that they're like there is a bit of modification in the layers, which is making it like more popular nowadays. All right. Hmm. Sorry. Mhm. Yes. Not exactly n number of layers. It will be depending on like you how you want to build your model. So if you remember in the continuous back of words and skipgram, there was one like step where I was talking about that build the architecture of the model, right? So that architecture has to be like chosen like select by you. Okay, so you have to decide how many layers you want and what kind of layers you want. So basically, this hidden layer has the same function in every node. Okay. So yeah, I mean, I was talking about like why it was famous earlier and all this stuff. So this is like this is fully connected layer neural network. So here you can see like each node is connected to the like so this layer is completely connected to each and every node of the next layer, right? And it is basically right now what is happening that we are giving the data to this network, and this data are like processing in a only a like forward mode only. That's why we call it like feed forward. So there is no like recursion sort of stuff is happening here. All right. So yeah. So we are going to like today we are going to see some examples that will be on like feed forward network. However, like there is one more network that is getting popularity for NLP. We'll be talking about that a bit as well. So yeah. So let's talk about convolutional layer a bit. I mean, we do not need it for our like problem solving today, but because it is an like introduction to deep learning, right? And because it is famous. So this is the part because of what it is being like famous nowadays. When the network is fully connected, it takes a lot of time. We cannot like scale the model. I mean, we have to run it in a single machine, right? So that was the like main problem earlier, right? But right now, what the deep learning does is like it doesn't have the fully connected layers. I mean, in order to find the final result, we will be needing one like fully connected layer. But the beginning of like we can have some layers which are not fully connected, and those layers can be actually distributed among. I mean, we can run that in a distributed environment. All right. So yeah, I mean, convolutional layer basically does that. Okay. So and because of that only, nowadays it is like famous as well. So this is kind of. I mean, I was trying to find one image like which can represent the convolutional neural network. So it's like this one only, right? So what happens? I mean, if we have to earlier, what was only this part was like present, right? So each and every like, for example, if we take an image, right? What it has like pixels, right? So earlier, what we have to do, like we have to calculate each and every pixel within this, like with a fully connected network, which is kind of not possible if, which is kind of not possible if the image is really very like high resolution, right? So all those self-driving cars and all those stuff, I mean, they have like high resolution cameras, and it is taking picture from them, and they're processing it real fast, right? They're almost giving it in real time. So this is happening because of that. I mean, what it does, like it takes parts of the image, right? It then reduces its dimension. Basically, it compresses that data, right? All this convolutional network does that thing, right? And it also like it has that like connected layers where it has the weightages, and it actually can calculate how what way we have to compress the data so that the fully connected layer later on can uh, create an input that and identify whatever the image has, right? I mean, if this is a like image of car, so this convolutional network finally can identify that this is a car, and yeah, so it takes parts of the image, distribute it to different like machines in a distributed environment, compress all those like data, right? It's basically called the dimensionality reduction, and finally it gives that data into a fully connected layer, and the like problem is solved. All right? Yeah, this is why deep learning is famous. Deep learning is like nothing but neural network only, but it just have like no more than one uh, hidden layer. Yeah. So then we have RNN. Okay, this is like recurrent neural network. This is also getting popularity on the NLP side. But yeah, I mean, we are not going to basically, I do not have any example for this today. Probably in later sessions, so we'll go through that as well. So in recurrent neural network, what happens? I mean, we have talked about the feed forward model. It just takes the input, passes on to the next layer, calculate the weightage, and then we are done, right? But in case of RNN, what it does, it keeps a state. Okay, it keeps a state, and that state is being like used like later on for the processing. Okay, so yeah, I also do not have a lot of context about RNN today, but yeah, I mean, hopefully we can have a session on RNN later on. So now, yeah, I mean, finally, introduction to TensorFlow. Okay, so what is TensorFlow? It's a open source library to do deep learning models, right? To do machine learning. Uh, so so yeah, I mean, whenever I have to like learn some tool, I just go to the architecture first so that I can get the a quick hang of it. I mean, what it is, and like how it works, so that the other APIs I can easily guess, right? So this is basically the architecture of TensorFlow. Okay, so it has this like it can run on CPU, GPU. I do not have a lot of idea about the networking layer. Okay, then it has the kernel implementation. Okay, so it has implemented this kernel implementation in like C languages, right? These are the like matrix multiplication, convolutional layer, ReLU layer. So these are the layers. These are the like parts which is actually like compressing the data, or like the dimensionality reduction stuff that I was talking about in the deep learning emails, if you remember, right? So this is done in a low level language, and this works. TensorFlow works in a distributed environment. Okay, so it just like I mean Spark. Okay, I remember I tried to like compare TensorFlow with Spark so that I can easily understand all the concepts. So what Spark has, I mean, the main components of Sparks are what I mean DAG and the RDD, right? So that is the like data flow graph, and RDD it's hold the like data, right? So in TensorFlow also it is almost the same. So Tensor holds the data. Like Tensor means, I mean, I think it's a it's the collection of like numbers. It's a vector basically, right? And the flow, the word comes from the data flow graph. Okay, so all the operations, right? If you go here, all the operations, this nodes has a like immutable sort of a function, right? Which if we give an input, it returns us that output, right? So these operations are like just like DAG, the data flow graph arranges according to itself, right? And it passes then it got like executed in different machines in the distributed environment, and then yeah, and that's the way it works. Okay, then it has a C API, right? using what the whole Python library is being like made. Okay, so right now it's like whenever it's TensorFlow, it's we have to like go through. We use Python, right? Why? Because it has implemented a lot of stuff already, but it doesn't mean like TensorFlow still can be like used for Java, Scala, or whatever the like languages that can easily access like C APIs. Right now there isn't any library which is probably, even if there is, I mean it is not that famous. Okay, so but like the Python libraries are. So yeah, I mean again the TensorFlow works in a master and slave architecture just like Spark or Hadoop, right? So yeah, I mean I think we already know about it. So there like then the TensorFlow has different layers. Uh, sorry, it has different libraries built on top of the C API, right? So one is like estimator API, right? So this is basically the layer which is directly interacting with the C API. So we can directly deal with the ReLU or the convolutional or the like matrix multiplication functions in the C API through these estimators. However, um, there is one more layer which is built on top of estimators. I mean, if you have to do really low level like work, if you want to build one like one model of your own and not using the like models that TensorFlow is already providing, then you can use estimator. Otherwise, it's Keras. Okay, so Keras has already built a lot of like functionalities for us. So if you want to like create one like deep learning model, it already has those layers into it. Okay, we do not have to write those like mathematical functions and all those stuff. We can just bring that layer into it, and then we can just combine it, and our model is ready, right? And we're going to see that as well. So now we're kind of end of the we are already have ended whatever the theoretical part that I wanted to tell, right? So here is the solution. Okay, what we are going to do, like our purpose is what? Our knowledge feedbacks. We're going to use the model globe, the global vector, in order to see, right? I mean, we are also going to see the skipgram model, right? But the skipgram model is somehow like I was unable to process it completely. Okay, so but with the globe, I mean, it is not 100% accurate, but somehow it is like clustering the data in a somewhat good. Okay, so we are going to see that, and yeah, we are going to apply the k-means clustering algorithm once we get the word embeddings, and we are going to use Keras and TensorFlow for that. Okay, any question you have so far? All right. So let's see the direct solution now. Okay, so so I'm using like Jupyter notebook. All right, so it is sort of like Python is giving us a very like good interactive UI. So I can actually run each and every step here, right? And we can see what we are doing. So first of all, I mean, of course, I also don't know Python very well, so I cannot like explain you each and everything. It's just the knowledge that I have from Scala and Java. Okay, so first we are definitely like importing all the libraries. So when I was talking about the global vector, what I told you, like there are like two sort of word embeddings. One is which is already like the Spacey guys has made, right, with I think some million words, right? So that is already present, and then so this is what it is, right? It is loading the data, and we are like keeping it in a variable called NLP. It takes some time because the embedding is big, but it reduces the time for our model to train. So whatever the corpus, no matter I mean how big our like corpus is, it can quickly train our model, and we are going to get the results. So it is taking time, but in the meanwhile, what we can do is like we can go through the, okay, it is loaded. So here, what we are, this is one function that we are going to, I mean, and these are the like tools that we are using to clean up the data a bit. This function is also getting used for cleaning up the data, right? We are removing some of the symbols from there, like dot and all those stuff, and we are also making it to the lower level so that we can, so that we can train our model flawlessly. So this is then we tokenize the data. So the way we are doing, I mean this is basically the cleanup part. I'll and at this part, what I'm doing is I'm loading the data. So I have saved it in a file called feedbacks, right? And I have started so I kept all those data in a variable called corpus. I have normalized the data. Basically, this is the cleaning part that I'm doing, right? I tried to then find out the unique words present in this corpus. And then what I have done is I have got my own model here. Okay, so I have passed my unique words to the already existing word embedding, and I have got the all the word embedding that I need in order to train my model. Okay, so these are basically the kind of data that we have. If I uncomment this, it will be printed, but let's not do that right now and remove the output. So this is a way to represent the table. I mean, Python is giving some cool feature into it, so you can see how the words got all these embeddings for each word. We have around there was I think 100 or some sort of embedding here. Okay, now let's go here. This is doing nothing but just for debugging purpose, I have added those printlns. Then, I mean, then we got this sort of graph representation for those data. I unfortunately I forgot to remove these words. If we have removed these words, then the image could have been a bit more scattered, and we could have seen the group of words that it is being represented here. So I don't think so. If you see, I mean, it has many dots here. So it's some similar words are getting grouped in the image. Okay. Then let's run it as well. It is not going to take a lot of time. Anyway, it is going to take some time probably. So I mean, once we get the word embeddings, what we have with us is we have the we already have the k-means model with us. We're just going to pass whatever the word embeddings we got after training all the model, and then we are going to get this sort of stuff, this sort of result. So these are some of the comments, and we have just labeled it. Okay, right now it is just the numbers, but we can easily have a map where we can easily map. I mean, if 1 is good or 0 is good, and then probably some of the numbers are not good. I don't know right now what is happening, but there was number 3 was sort of okay. We are not seeing all the data here. Somehow it is skipping the data. So basically, it's most of the feedbacks which are sort of negative. It was assigned the number 3, and rest of it it was divided. All the good comments were divided into 0, 1, and all the stuff. But again, as I have told you, this is not completely accurate. It is not resulting accurately. So some of the good words also getting the level 3, which is kind of representing as the bad comments. You can see whatever we have done right now doesn't include any deep learning sort of stuff here, right? I mean, it is because the Spacey has used it internally. It has given us these these functions using which we can directly pass our input data, and we can easily get the results. But let's go through the skipgram as well, so that we can get the hang of keras and all the layers that it has, and how it is building all the models, all the neural networks, right? So again, we have the import, we have this cleaning up functions, right? We have imported the keras library here as well. Okay, let's go skip the. So let's skip the cleaning up part and let's go to the network modeling part. Okay, so here we are actually designing our model. Okay, so we are trying to build one network, right? So this is the way it is doing. We have the input model, so we have the word input and the context input, because it is skipgram, right? So we have to give these two inputs. So this is the input layer that we are using, right? And then and if you see, all these layers are from what? Keras, right? So this input layer or the embedding layer. So embedding layer is what I mean. Whenever we're directly passing the words to it, and it automatically basically the embedding layer can understand the word embeddings clearly. Okay, then okay, so we have this is our basically the model we are using, input layer, embedding layer. Then we are flattening the data. I mean, this is almost sort of the same that we have in the collection of Scala. If we use the flat map, for example, if we have a list of lists, it will just remove the inner list and give us one single list. So it also does that sort of stuff only here. Then we have this dense layer, which is we can compare to the fully connected layer. Okay, so and we can see our model. I mean, again, the Jupyter notebook is providing us some sort of good visualization where we can see how we have actually created our network. So we have this input layers, then it is being passed on to the embedding layer, which is understanding the word embeddings. Then we are flattening this data because we need to do some matrix multiplication into those data, right? And that need to be flattened. And then we have done the dot product, and then we are passing it to the dense layer. Okay, so this is the part where we are actually training all the data. We have created our corpus through a utility that Keras gives us. We are using that tool for this one, and then we got this inputs that we need to pass on to the network, and then we start processing it. If we're done with the so we can skip a lot of part. Yeah, so here we are trying to get the weights for the merge layer, through which we can easily. I mean, that merge layer is the word embedding that we want in order to verify our words. Okay, so yeah, in the end we are again applying the k-means algorithm, and we are getting the results here as well. But this time, I mean, this is we were seeing the complete sentence in the globe one, but here we are only seeing the unique words of the sentence and its level. So yeah, I mean, a bit of engineering what needed to be inserted here, but yeah, I mean, probably I have already pushed the code into my repo, and you can probably take a look and yeah, try it. So yeah, I mean, that's what I have. I have an example for C continuous bag as well, but this is not related to the problem that we were doing. Okay, so do I have time or let's go on? Okay, so let's probably talk about the continuous bag of word later on as well. Okay, yeah. So that's all from my side. If you have any questions, you can ask now.
One thing was regarding all three that you had this table where there were words on this side, there were numbers on that. What is that? What does that mean?
Oh, okay. That is the thing we wanted to do, right? So that is the categorization, right? This one.
Yeah. What does this mean?
Okay. So this is sort of like, this is what I'm calling the word embedding. Okay, this is the word, and it's sort of, you can say, so in order to, there are a lot of words, right? So what would be the distance? So we are keeping a, like, size. Okay, like, this is 100 words. I just want, like, distance this word from this 100 words, right? So I have this word, and then I have, like, 100 other, like, distance from 100 other words. Okay, so any other questions? Okay, thank you then.